So, very good morning, students. Welcome to IIT NEET Foundation or Focus C program by Krishnaveni Talent Schools and the Mastermind Schools. So, once again, I welcome all the class 7th students for today's session. As you all can see on the screen, and you are well aware, my subject is physics. We are in class 7th. Our ongoing chapter, chapter number 1, is units and measurements, and we are entering into the session number 4. So far, we completed the 3 sessions in understanding what is the importance of units and measurements of various physical quantities. So we'll continue where we left in the last class. But before that, let us have one glance into the topics what we covered so far. Right. Here you can see in one single slide. So physical quantity, fundamental quantity, derived quantities, unit, system of units. Then we enter the measurements. We have seen how to measure the length, mass, time, area, and volume. Right? How to measure the length by using scale, by using tape, right? By using the arms, by using so many ways you can measure the length. Similarly, mass also with the help of various balances, time with various watches, area. We have seen how to measure the area of the regular surfaces and irregular surfaces, and volume of the solids, regular solids and irregular solids, and volume of the liquids by using the various devices, like pipette, burette, flask, jar, measuring flask. So many are there to measure the volume of the regular and irregular bodies, right? That we have seen. So today we are almost going to close the chapter with some more points, some more topics, like how to measure what is density and relative density. So we have seen mass, length, time, area, volume. How to measure. Now here we are here to discuss about how to measure the density and what is relative density. Right? So density, you all know density is nothing but mass by volume. Density is equal to mass by volume. Right? So if we compare the masses of different substances of same volume, we find that mass will be different. For example, the mass of certain volume of iron is greater than the mass of the same volume of the wood or cotton, anything. Why it is so? This is because atoms in iron are more densely packed, closely packed. Then the atoms in the wood are other words. Density of iron is more than density of wood. The density is defined as mass per unit volume of a substance. Thus, density is equal to mass by volume. The SI unit of density is kg per meter cube, because mass is measured in kg and volume is in meter cube, or gram per centimeter cube in CGS system. Okay, that is given here. So density of 1 gram per meter cube is 1000 kg per meter cubes. So density of water is always 1 gram per cc or 1000 kg per meter cube. Density of ice less than water 0.8 only. Right? So density is nothing but the mass by volume is defined as a density. It is measured in meter per kg per meter cube or gram per centimeter cube, and these two values are very important. Density of water is 1 gram per cc, whereas density of ice is 0.9 gram per cc, less than the water. 1000 kg per meter cube, 900 kg. Right? So how to measure the density? So determination of density of solid by using measuring cylinder. Divide the mass of the solid by its volume, given its density. That is mass by volume. Right? What is the mass of that? You can measure by common balance divided by volume occupied. Volume already we have seen. To measure the volume, there is a mathematical formula is there. If it is a solid body, the liquid body, there is a measurements are there. By measuring them, you have to divide them. The mass of the solid can be determined accurately by using physical balance. The volume of irregular shaped solids can be determined using the jar. I told now, whenever you drop that irregular body into the water, how much water is overflown, that is considered as the volume of the irregular body. So when you know the mass by physical balance, volume, you can divide them and you can get the what is the density of that particular material. Okay. Hope you are clear. Mass by volume will give the density of that substance, maybe iron or it may be gold, anything, no matter. Right? Now, relative density. So the ratio of density of substance to the density of water. The ratio, it is ratio. Right? So relative density is nothing but density of substance by density of water. Because water is constant 1 gram per cc. So you can, by using this formula, you can find out relative density. See here. Is also called as specific density. Relative density or specific density or specific gravity. Since this ratio of the density, it is mere number, because ratio, number without any unit. A specific gravity bottle is used to measure the relative density. A separate device called specific gravity bottle to measure the relative density of any substance, because we know about the relative density of water. So relative density of substance is defined as ratio of density of substance to density of water at 4 degrees Celsius. So water will show some special property at 4 degrees. Means constant value, that is 1 gram per cc or 1000 kg per meter cube at that particular temperature. So we'll take that as a standard. Right? Relative density has no units because it's a ratio. Ratios does not have units. So the density of liquid can be found as follows. Right? The formulas to find the density of liquids. Mass of the liquid by volume of the liquid divided by mass of the water by volume of the water will give mass of the liquid by mass of the water. By knowing that, you can find out. As density of substance is the ratio of mass by its volume, if equal masses of different substances are taken, different cases, there are special cases. Rho 2 by Rho 1 is equal to V2 by V1. And Rho 1 by Rho 2 is equal to M1 by M2. In terms of volume, you can find out. In terms of mass also, you can find out. When volume is same and mass is same. There are special cases to find out the relative density whenever volume is constant or mass is constant. Correct? So this is about the relative density and density. So before going for the next, based on this, there is a worksheet here. You can easily can do easily. Just have that knowledge and you can do the right. So before going for the last topic, I'll show you one video on density and relative density. Later we can move to our actual topic, right?
We've understood what density is. In the same given amount of space, if there are more things, we say that it's denser. Density is simply the measure of how compact the mass in a substance or object is. It's mass per unit volume. And based on this formula, we can say that its unit is kilogram per meter cubed. So can you tell me what relative density is? Look at the word relative. What does it tell you? It tells us that we are looking at the density of something relative to the density of something. We are comparing the density of one thing to the density of another. That's all. But the question is, relative to what? It's most typically the density of water. Yes, we look at the density of an object relative to the density of water. How do we define the relative density of a substance? It equals the ratio of its density to that of water. Yes, density of the substance over the density of water. Can you tell me the unit of relative density?
No units.
Look at the right-hand side and tell me the unit. As it is a ratio of similar quantities, relative density will have no units. The units from the numerator and denominator cancel each other out. The density of water is 1000 kilograms per meter cubed and the density of silver is 10,500 kilograms per meter cubed. So can you tell me the relative density of silver? It's easy. Just refer to this formula and try answering it.
10.5. Just 10,500 by 1000.
It will equal the density of silver over the density of water. Substituting the values here, we get the answer as 10.5. That's the relative density of silver.
The number only. Means 10.5.
What does the relative density tell us though? What can we understand from this? First, it tells us that silver is a lot more dense than water under the given conditions. Approximately 10.5 times denser. But that's pretty obvious given the numbers. This tells us another important thing. It tells us whether the object will float or sink in water. In simple terms, a substance will sink if it's denser than the liquid it's placed in. And it will float if it's less dense than the liquid it's placed in. How can we say this mathematically? If the relative density of a substance is greater than 1, then it will sink. And if it's lesser than 1, it will float. As the relative density of...
Very good point here. Relative density will clearly proportional to whether body is floating in the liquid or sinking in the liquid. If relative density is more than 1, relative density is the density of substance with water. So see now just now your silver 10.5 times more than the water. So definitely silver sink. If you take any other substance, light substance like wood or cotton, if that is greater than, relative density is greater than 1, body will sink. If it is less than 1, body will float. If both are
silver
same,
is 10.5, which is greater than 1, it will sink in water. But if we take the example of ice, its density is approximately 934 kilograms per meter cubed.
Less than water.
So its relative density will be 0.934. As its relative density is lesser than 1, it will float in water. We can understand this with a simple diagram. Take 4 beakers filled with water. In the first one, drop a substance with a relative density of 0.1. You'll see that it floats like this. In the second one, drop a substance with relative density of 0.4 and you'll see that it floats like this. More of it is inside the water. And if it's 0.9, even more of it will be inside the water. But it will still float. And if it's greater than 1, say 1.2 or 1.3, then it will sink.
It's clearly...
Okay. Here
it is completely clear. Whenever the relative density is less than 1, they'll float. Floating maybe see difference. 0.1 somewhat part is different. 0.4 little more part is inside the water. 0.9 more part is inside the water. But when it is more than 1, it is shrinking.
There's one last question for you. Can the relative density of an object be 0? The answer is no. It can't be 0. Because if the relative density is 0, it will mean that the density of the substance is 0.
There is no chance.
Which in turn will mean that the mass of the substance is 0. For any given substance, its mass in a given volume cannot be 0. And you should also know that relative density is constant only under given conditions. It is pressure and temperature dependent. The same substance can have different relative densities under different pressures or temperatures.
It will change along with the pressure and temperature also, right? So that is about completely about the density and relative density. So density is nothing but mass per unit volume, whereas relative density is nothing but density of any substance with respect to density of water. As you know, density of water is 1000 kg per meter cube. We can find out the density of the other substance by finding its mass and volume. Okay, then we'll come to the last part of the measurements. While measuring the things, this also plays very important role. Dimensional formula, right? And dimensional formula of the some physical quantities. So this dimension formula helps us to know about the nature of physical quantities. So dimension of the physical quantities are power to which fundamental quantities are to be raised. So for example, mass is there. We have 3 fundamental quantities: mass, length and time, basically. Of course, more are there, electric current, temperature and all. So what is the dimension formula of mass is nothing but m1. Dimension formula of length is L1, T1. So even you can write, so this is called, the power is there, now this power is called dimension. The dimension of mass in mass is 1. The total representation is called dimension formula. For example, if you ask dimension formula of the speed, you know distance by time, right? Distance by time. So what is distance is nothing but length only, L1. Time is T1. T1. So it's considered L1. When T1 goes up, it becomes T minus 1. If you want to calculate M0 also, mass not there. So L1 T minus 1 is the dimension formula of the speed. So for every physical quantity, we can write the dimensional formula, which makes us to understand the physical quantity and its nature, right? An expression showing the power to which fundamental quantities are to be raised represent derived quantity is called dimensional formula. The complete expression is called dimensional formula and the power is called dimension. The physical quantity which have dimensions and have fixed value are called dimensional constants, right? So dimension formula. An expression showing the power of to which fundamental units are to be raised to obtain 1 unit of derived quantity is called dimension formula of that particular quantity. Okay, there are a lot of uses are there with dimensions. We'll come across in the next classes. But before that, you should know how to write the dimension formulas. So dimension formulas of the physical quantities. See, length, I told you, L1. M0, T0 you can mention. L1 is there. Right? So the unit of length is meter or centimeter. The dimension formula of time, M0, L0, T1. Okay? Basic fundamental quantities. So when you move to further, there are so many you can see. You can see the so many physical quantities. Suppose if you go for area. So formula for area is length into breadth. So length is L1, breadth is L1. That is equal to M0, L square, T0 you can write. This is called dimension formula. So this is called dimension. Dimension of length in area. If you ask, given 2. 2 is the dimension of length in area. Suppose volume, length into breadth into height. That is L1 into L1 into L1 because all lengths only. That is equal to M0, L cube, T0. This is the dimension formula. This is the dimension of length in volume. The power to which fundamental quantities are to be raised. See how interesting, very interesting. They have also having a lot of use also in solving the problems. We'll know in future, right? Then density. Just now we discussed density. Mass by volume. Mass is M1. Volume is L1 into L1 into L1. Right? That is equal to M1 by L cube. Or you can write M1 L minus 3. Of course, T0 you can write. No matter. So this is the dimension formula of density. So what is the dimension of mass in density? If you ask, you have to write 1. Dimension of mass is 1. Dimension of length is minus 3. In volume. Speed already we have seen. Acceleration. Acceleration is nothing but velocity by time. Velocity is nothing but distance by time. Distance by time by time. That is distance by time square. So distance is L1. Time square is T2. That is L1 T minus 2. You write M0. Acceleration. Similarly, momentum. Mass into velocity. Already we have seen your mass is nothing but M. Velocity is L1 T minus 2. L minus T minus 1. That is speed. Force. Mass into acceleration. You know mass? So many, everything you can write. Any physical quantity you can mention you can write the dimensional formula, right? Suppose force. Force is the mass into acceleration. Mass is given by M1. Acceleration is given by L1 T minus 2. This is for the force. Suppose pressure. Force by area. Force already written here. M1 L1 T minus 2. Area is nothing but L square, length into breadth. So I can cancel the L1, L. One L will be there, come top. That is M1, L minus 1, T minus 2 is for the pressure. See here. Work. Work is nothing but force into displacement. Force already written M1, L1, T minus 2. Displacement again, yes, is the L1 only. Length. So it can be M1, L square, T minus 2. For the work done. Work done is nothing but energy. So energy also same will get. So suppose you want for power, right? Power, you can see the 11th one. Power is nothing but work by time. Already we know work here. M1, L2, T minus 2. Sorry, T minus 2. Correct only? Right? So already T is there. You can get M1 by T. Work by time, no? T1. So when go up, it becomes M1 L square T minus 3 for the power. Like that, for any physical quantity in physics, you can write the dimension. But for that, you need to have the formula. If you know the formula, you can write dimension. And these dimensions are very much useful in the deriving the equation, finding correct, checking the correctness of equation. And so many ways it is useful for us. Power, see, 11th one. 12th, impulse. Impulse is nothing but force into time. Okay. You can find that 12th one. Impulse. Right? Impulse is nothing but force into time. You know, force is nothing but mass into acceleration into time, T1. So it becomes 1 will cancel here. Minus 1 will be left. M1, L1, T minus 1. Same thing here. Then angle. Angle also a fundamental quantity. Remember, two solid angle and plane angle. So it's simply measured in radian only. Dimensionless. Frequency. Frequency is 1 by time. Frequency is nothing but 1 by time. That is 1 by T1. That is equal to T minus 1 for the frequency. Like that, you can prepare wonderful chart. You can prepare the wonderful chart with all the physical quantities which you have seen in the beginning of the chapter also. You write in one table side and write their formula, their unit and dimension. Like that, you can prepare one chart and display in your classroom. Right? Simple. Serial number, physical quantity, units, no, formula, then unit, and finally dimension formula. All these you can paper like a table, right? Like this table, you can write any more than 100 physical quantities you can write up to your standard. Serial number, physical quantity. For example, first you start with the mass. Formula, mass is nothing but M only. Unit, mass unit is kg or gram. Then what is the dimension? M1. Like that, you can mention and write for all the quantities. Here we have 14 only. But when you go earlier also, this chapter you can find many more. Okay. So you prepare one chart and display as consider it as your weekly project or project work. Even every alternate Saturday you do project work, consider this as a project work and do it and display in your classroom all the units and dimensions and formulas which you can recall whenever you want, right? So finally here we have dimensional equation. An equation containing the physical quantities with the dimension formula is known as dimensional equations. So when you go to the higher classes, next classes, we are going to have what is the uses of dimension formula and what is the advantage of dimension formula, what is the limitations of dimension formula. These dimension formulas are not applicable everywhere. There are some exemptions are there. That all will come across in the next class, 8th class. Okay, but right now you are just learn about what is dimension and what is dimension formula. right? And how to write the dimension formula of the given physical quantities. Okay. I can see here first few examples you can find. That first one definitions only. You can find this third one. What is the dimension formula of the velocity? So velocity, and you can recall formula. Velocity is nothing but displacement by time. So displacement is nothing but L1. Time is nothing but T1. That is M0, L1. T1 will go up, become T minus 1. Bracket is very important here. So check which one is this. L1, M0, L1. Right? M0, L1 here. L1 is all L only. M0, T minus 1. This is answer is B. Dimension formula of area. Area is nothing but formula you have to recall. Length into breadth. Right? L1 into L1. That is L square. L square T0 M0. You can see where it is. So M0 L0 T square. M0 L0. Where is the T square you have to see? Sorry, L square. L square is here. So M0 L square T0 is the unit for the area. Just I didn't write the formula and then write the dimensions. Easily you can find out. So dimension formula of the volume. Dimension formula volume. You know what volume is equal to? Length into breadth into height. That is L1 into L1 into L1. That is L cube. So M0 L cube T0. Check where it is. So here B is the answer. So general formula of acceleration, change in velocity, rate of change of velocity. Change in velocity by time is acceleration. General formula of momentum, mass into velocity, we have seen just now. The general formula of force, mass into acceleration. Means when you want to know about the dimension formula, you must know about the formula. First you should perfect in formulas. That's why I asked you to write first column serial number, second column physical quantity, third column formula, fourth column you can write the unit, fifth column dimensions. They're all helpful for you everywhere. Wherever you go, you need to make use of formula and units. Without units and diamond units, there is no meaning in the physics. Right? General formula of the impulse. Impulse just now we have seen. Force into time. Force into time is called impulse. That is D. You can find here. So if you know the concept, within no time you can answer the levels questions. Right? So like that you completely answer them as you can see. So before closing, let me show one. Right. So overall, when you go through what we learned till now, so total chapter once you recall, right? When you recall the entire chapter of this one, with this we have completed the total chapter starting from unit C. When you recall once again, we started with the what is the importance of measurements in physics, right? Why measurements are important? Not only in physics, in our day-to-day life also, measurement plays very important role. Okay, so we learned about what is the physical quantities, how they are classified into fundamental physical quantities and derived. These are the fundamental physical quantities: mass, length, time, temperature, luminous intensity, electric charge, and current, amount of substance. Apart from this, these two supplementary quantities are there: solid angle and plane angle. Then what are the derived quantities which are obtained from fundamental quantities are called derived. Okay, so there are so many derived quantities are there, like area, volume, density, pressure, force, all C. Velocity, acceleration, force, all are, and all these units are studied under system of units: FPS, CGS, MKS, and finally SI system. Okay, then special quantities of plane angle, solid angle. You can answer these questions based on that particular topics. Okay, either level 1, level 2, level 3, no matter. You can easily answer. Then we studied about what are the multiples and submultiples, which are generally used with the prefix of the units. Multiples are the largest powers. Submultiples are the negative powers. So they are 10 minus 3, 10 minus 6, 10 minus 9, 10 plus 3. How they are called, where they are represented is given. Multiple factors. Right? So after learning about the multiple factors, multiples and submultiples, we move to the how to measure length, measurement of length and time by using the various devices, and measurement of, after learning about measurement of length and time, we enter to area, how to measure the area of the given object, right? It may be regular body, regular shaped body, or irregular. With regular shaped body, you can use the mathematical formulas. Irregular shaped bodies, you can use the methods. See here. We've already seen how to, what is the area of the circle, rectangle, triangle, square, sphere, polygram, parallelogram, ring, cylinder, circle, and irregular surfaces. You can use the graphical methods. Then volume, we enter into the volume after knowing about area, right? So volume, how to find the volume of the solids. In that again, regular solids and irregular solids, and liquids also their volumes. You can find the liquids. So these are regular solids, mathematical shapes, that is cube, cuboid, cylinder, cone, sphere, hemisphere. Then how to measure the liquids by using the various flasks, right? So how to measure perfectly. See, these are the devices measuring the volume of the liquid, measuring cylinder, measuring flask, pipette, burette. Explanation is given. Okay, this is about the volume. Now today we are entering to the what is how to measure the density and related density clearly. After learning about density and related density, we enter into our last topic of the chapter, dimensional formulas of various physical quantities you have seen. Okay, you can practice them and you can complete the assignments soon, so that you can next class will see the second chapter, that is kinematics, right? So that's all for today, what we learned. Okay. Right. So that's all for today. Thank you, students. Have a wonderful day. Thank you.